steps result. I have also have the future thoughts so that my following people can move it forward. Also, I have the appendix for academic purpose.
Great.
Okay, for the goal. The goal of this project is to explore decisive customer attributes that will lead our customer to buy an alternative investment product. Use the determined correlation sectors to accurately predict potential customers' investment behaviors that can improve our advertisement pushing accuracy and reduce the cost of sending an advertisement. And because of the complexity of the alternative investment market, we shift the goal, shift from alternative investment to retail digital market. But the tag is same. The tag we use in retail market will be the same tag we use to analyze the factors in alternative investment. Sorry. Okay. Prerequisite. First, we need the data. And I collect data from the data right. I bought the data from the company Driven IQ. And since this is a true data company, so it collects the data from all of the world. And I filter the result. I choose US, choose the English as the main language. And my following people, they can choose their own filter so that they can have their own data, own unique, useful data. And the second step is the software we use is an IBM SPSS modeler. Here I put a link so that you can download the SPSS modeler. And what is this software? This software is a data mining and predictive analysis software. Use algorithm to create predictive models without programming. So if you don't know how to code, that's fine, totally fine. And it can reduce the difficulty of data analysis. Okay, those are the variables I want to examine. I want to find the correlation of all of those variables and my target income. I set the income, annual income as my target. Okay, that is the overall work I do from the start point to the end point. And here are the two prerequisites you need to know to start the software. How to create a line from the start point to the end point. We need to right-click the node and choose to connect to the next node, or just press F2 to connect two nodes. And keep in mind, always click OK when you finish any operation in any node. Those are just the two prerequisites. And if you have those two prerequisites, fine. Okay, steps. In the source tab, you need to read the data from the source tab. Use the Excel file read to read the data from the Excel to the SPSS modeler. Here is the operation process. You need to select the file and just input. Step 2. In the output tab, use the table node to examine the data. The purpose of this step is to check whether you read the data correctly. Because if you can't read your data, then nothing else you can do. Okay, step 3. In the field option tab, use the direct node to quantify inputs. For example, one input of my variable is the gender. So I set male, I set male as 1 and female as 2, and you can quantify any variable by using direct node. Here is what happened in the direct node. In the upper right rectangular, you can define your name. And down below there is a formula I input to how to quantify the variable. Okay, step 4. In the field option tab, use the filter node to get rid of those used data for creating new data. So in the previous example, I already quantified the gender. So in this step, the word content gender should be filtered, and the quantified gender should be retained. And note, oops, one second, I should frame here, is that double click the right side of the field. It's the right side of this field. You can change the name, you can change the variable's name. And the reason we do that because of this. In the real world, we can append 2 tables, just combine them to form up a new table. And SPSS modeler can do this. How to do this? Because they need to combine with the same name. They must be combined, use the same name by the merge node in record option tab. That is why you want to change the name. Okay, back to our step. Step 5, in the output field, use the data LDAT to check the completeness of the whole data set. And the purpose of this step is to impute any missing value you have in your data set. Okay, that is a tricky part because this step is a little bit difficult. Double click the data LDAT and choose quality. Then you can see the percent complete. If it's not 100%, that is a step you need to do. Choose blank and non-value and choose a method algorithm. That's step 1. Step 2, select those data you need to impute and select the field only. Choose the sample size 100% and click OK. Then click generate a missing value supernode. You can impute those missing values. Okay, after you impute missing values, you can to step 6. Use the direct node again to set the target. In my data set, I set the $100,000 as annual income as a dividing line, true for purchase behavior and F for not to buy. The reason I said $100,000 because they are minority in my data set. Like in the real world, rich people, they are minority. So the tag I use in my data set is the same tag we use to trade in the real world. Step 7, in the field option tab, use the tab node to select the target. You need to let the model understand what is your target, what is your prediction target. That is why I need the tab node here. Okay, double click, open the tab node. In the raw column, set the income level as our target. And also in the measurement column, you can choose a different type. You can choose a different attribute of each variable, but be sure you can provide every strong evidence if you want to change it. Otherwise, just keep default. Okay, step 8. In the modeling tab, use the future selection node to select the variable input, because we obtain the data from real world, not every factor is useful. That is why we need a future selection. Okay, for the future selection, input target, that is what you want to predict. And inputs, what variable do you want to use to build up the relationship with the target? Just like examine the correlation between your target and all the inputs. Okay, run the model. Here is the result I have. And step 9. Okay, we are good to start the model and you treat the data. In the field node, use a partition node to split data in training and testing part. Training part is to establish the model, and testing part is to examine the model to check if our model is suitable for our case. Partition node. Double click to open the partition node. That training size of 70 and testing size of 30%. This node will randomly select 70% of the data to establish a model. Just the right rectangular, and everywhere else just use the default. Step 10, in the record option tab, use the balance node to balance data. The purpose, because we want to predict the minority. And if we don't balance the data, the model or the models we use will regard our target, the minority, is an outlier, and then we can predict nothing. That is why we need balance node. This node is really important. The balance node try different number in the factor columns to make sure people buy and people not buy, they have 50 to 50%. So the model can randomly pick up each behavior and predict. The upper screenshot is data before we balance. You can see here the people buy just 60%. And after balance, they almost have equal chance to be selected. Okay, then step 11. In modeling tab, choose the shade node. That this mode is well known as decision tree. And I also attend the academic in Appendix. Okay, double click to select the target, the income level. The income is the target, and input all the predictors selected in after you run the future selection node. In a collect build option, choose the objective, select launch interactive session. This will give you a chance to choose your own predictor to create your own model. Then click run. Okay, that is a screenshot of after you click run of the interactive model. This step need a lot of trial and error, so you need a lot of time on this step. Right-click group branch with custom split. Okay, here is what happened. In the defined split, choose custom and create another branch. Here we have 2 branches, but if you don't, but if you think you need more branches, okay, then you can click the node on by the node 2. Then change the range by node 3. And you can also choose another predictor in node 4. again, set the condition. Here is a condition below 1 by node 2. It's like expand your branches. And collect 6 and collect grow to grow your branch. Okay, so after above steps, you can create a branch like this one. This is my final result, the screenshot of the my model. It has a lot of branch, so I make a screenshot, just 4 branches here. Okay, then collect the generate model. It will gives you a diamond model, and then you need to double click, open it to see the results. And also you have the analysis and statistics node to quantify your result to see if this model is okay or not. How to examine my model? In the output field, use the analysis node and statistics node. Those are the 2 screenshots of the node I use. Okay, double click the analysis node, setting do things like the screenshot on the left side. And for the statistic node, examine the income and examine the correlation of every input. Okay, here is a numerical result. We use the AUC value to judge our model. Typically, the AUC value should fall into the range of 0.7 to 0.85. And the testing AUC value, okay, in this range. And if the AUC value higher than 0.9, then probably you need to recheck your model. Also, if the AUC value is below 0.7, that means the model you created is not suitable. So you need to do step 11 and 12 again until you have an AUC value between 0.7 to 0.85. Okay, here is my statistics node results. I derive the output into the Excel file and make a screenshot here. Here you can see we have the target. We also have all the factors below and the numerical relationship correlation between each factor and the target. And in the E column, I have the explanation of each factor. Okay, for the future start, in step 3, I just quantify the input variable from word content to numerical content. And another start would be you can use the derived node to create new variables to improve the accuracy. For example, if you think the total expenditure will have the relationship with the target, then okay, you can, and in your input, you also have the pass fee, you also have the education fee, you also have the repairing fee. So you combine all of 3 to form up a new variable. But keep in mind, once you have established a new variable, those used variable, 1, 2, 3 in parentheses must be filtered out. Otherwise, you are using those variables again and again, and that doesn't make any sense. And in step 11, there are other models that you could use for the prediction. I use the decision tree model, and my follower could use the neural network model, use the support vector machine model, and use another software to double check my outcome. The reason they want to double check my outcome, because if you use 2 methods and you get the same result, then your result has the strong value. And also detect if the SPSS modeler could deal with the word content. It's like machine learning. Okay, in the appendix, here is the decision tree. The decision tree, the algorithm, the supervised algorithm I use in my modeler. Here I just provide an example. And in the second appendix, I have the AUC value of what is AUC value and how does that work. And in the appendix 3, I have, because I mentioned before what is overfitting and what is the right line. X are the input and lines are the models we want to create. We want to avoid the right dashed line of overfitting because that can predict nothing. Okay. So that is everything I have. Thank you. I finished.
Yishin, I have a question. Can I ask you a question?
Sure. Yes, yes.
How did you take care of the overfitting? How did you find that line to avoid overfitting?
Oh, to avoid overfitting, decision tree is easy to cause overfitting. Here is the result. You can see, 1 second, let me. Okay, we use the training model to training data to create model, right? Here is the AUC value of training AUC. If those two AUC values, if they are close, then okay, you probably don't have overfitting problem. If the training AUC value high enough and close to 1, and the testing AUC value small, close to 0.5, then probably you have overfitting problem. If those two AUC values close, then probably you don't have. That is how I avoid overfitting problem.
Okay.
And also, if the testing AUC value is higher than the training AUC value, that means you have an underfitting problem, and you need to redo your work.
Yeah, that's what I wanted to ask you. You mentioned it, the underfitting problem. Okay.
Okay, sorry, I was muted. So what's the end result for Alan?
Well, the final result for Alan is we to examine the income target. We have the factors here. The first one, the important first one is a family type, and the second one is if you have mortgage, and the third one is adult in household. The fourth one is a credit level. The top 5.
Voice is strong.
Yeah.
So the family type is what's driving the decision.
Yes. Yes, that's my result. And if you have mortgage, then also important.